If angle of prism is small, what would happen? Yes? Angle of? Yes, that's true. But when we are looking at angle of prism and our angle of prism is given by R1 plus R2, A is small, it would mean that R1 and R2 both are small. Because A is small, so sum of R1 and R2 is small, so R1 must be small, R2 will be also small. Now, if you are having R1 and R2 small, what will be the relation of I1 and I2? What will be I1 and I2? Increase or decrease? Increase. Down arrow, up arrow? Why should be I should be greater? Why I should be greater? How come it will be independent? You can see the figure here. Best. In this, I1 and R1 has been shown. If R1 is small, I1 will be more. You are aware of the fact that R1 is decreasing, so I1 should be also small. I1 and I2 both will be small. So if you are having a situation that I1 is equal to I2 is equal to I, very small, then what would happen? That is the part we would like to discuss. So put it down here. You have written up to this part. कहाँ तक लिखा है मेरे ख्याल से? ये लिखा है ना, ये स्टेटमेंट में लिखा नहीं है. If angle of prism A is small, if angle of prism A is small, comma, R1 and R2, and hence I1 and I2, will also be small. Since for small angles, sin theta approximately equal to theta, the Snell's law at the first and the second surfaces, of the prism, first and the second surfaces of the prism gives respectively, what is the formula for refractive index? Refractive index, we are writing it sin I by sin R is equal to, but if angles are small, sin I will be approximately equal to I, sin R will be equal to R. So can I write down from that the value of I1 will be equal to mu times R1 and value of I2 will be equal to mu times R2? Can I write down like this? Together, I am calling this as equation number 4. So if I add both the equations here, I will be able to write down I1 plus I2 is equal to mu inner bracket R1 plus R2. So I can rewrite this as equal to mu multiplied by A. So delta, which is taken as I1 plus I2 minus of A, will become here mu A minus of A. So I will be able to write down mu minus of 1 multiplied by A will be the angle of deviation. हो गया ये? Finished? Write down. Minimum deviation. Under that, mention for a given angle of prism, comma, material of prism and light as the angle of incidence increases, angle of deviation first decreases, comma, reaches a minimum value and then increases. So you are having a figure here. This is representing angle of deviation against the angle of incidence. The nature of the graph would appear to you like this. This is the point where you are having angle of incidence is equal to angle of emergence. For this particular condition, you will be defining here delta minimum. It is denoted also by delta M. Delta M stands for the minimum angle of deviation. In this case, we are considering here the refractive index, the wavelength of light and angle of prism are constant. We can perform the experiment and get the same nature of graph. So nature of graph is telling us here that from the study that we can make of delta and I, this is keeping constant. Delta minimum is obtained at this particular point when angle of incidence and angle of emergence are equal. Now, angle of incidence and emergence are equal means you are making the angle of incidence in such a manner that angle of emergent is equal. यानी इस diagram में you will be able to say that I1, this is I1, this is I2, they are equal. Able to get it? When this will happen, you will be having the minimum deviation. The deviation will then become minimum. Deviation, you are aware of the fact. डेविएशन कैसे होता है? प्रिज्म में ये वाला एंगल जो था दैट इज एंगल ऑफ डेविएशन. ओरिजिनल पाथ का है, फाइनल पाथ का है, वो कहां से कहां टर्न हो गया है? इट इज टर्निंग इन अ क्लॉकवाइज डायरेक्शन, right? So this is angle of deviation. So that angle of deviation would become minimum under this situation. Okay. Write down. When I1 is equal to I2 is equal to I, comma, when I1 is equal to I2 is equal to I, Snell's law at the faces AB and AC respectively, Snell's law at the faces AB and AC respectively gives Snell's law at the faces AB and AC respectively gives. Now you are having the faces AB. Our condition is that I1 is equal to I2. So here we are having air medium. The refractive index of air will be taken as equal to 1. So I will be writing 1 sine of I, because I1 is taken as equal to I2 is equal to I for minimum angle of deviation. That is equal to mu multiplied by sine of R2. This is at the face AB. Am I writing correctly? Then for the face AC, I will be writing here mu multiplied by sine of, sorry, this is R1. फेस ए बी की बात कर रहे हैं ना, तो ये R1 है यहां पर. ओके, at the face AC you will be having sine of R2 is equal to, you will be having 1 into sine of I. So if I combine these two equations, I will be able to write down mu sine of R2 will be equal to mu sine of R1. So factor mu is getting cancelled. Sine R2 is equal to sine R1 means R2 will be equal to R1. Let me put it as equal to R. बराबर है या नहीं है logically? If you are having the small angle of prism where R1 and R2 are small, then I1 and I2 will be small. Under that condition, whenever you are having angle of minimum deviation, I1 is equal to I2. When angle of minimum deviation is getting defined, you will be having I1 equal to I2. So R1 is also equal to R2. So under this situation, can I write down the angle of prism A is equal to R plus R is equal to twice R. So you will be having R is equal to A by 2. Can I write down like this? Can I write down? We are looking at angle of minimum deviation. Angle of minimum deviation will happen when angle of incidence and angle of emergence will be equal. So under that situation, can I put it down that angle of prism would be equal to R plus R? In that case, angle of refraction would turn out to be A by 2. Similarly, angle of minimum deviation here, I'll put it down delta minimum will be taken as equal to, you are writing the formula I1 plus I2 minus of A. But I1 is equal to I2 is equal to I. So delta minimum will be taken as equal to twice I minus of A. So I can rewrite this relation as delta minimum plus A divided by 2 is giving me angle of incidence. So refractive index of the medium with respect to the air, or I can put it as denser medium with respect to rarer medium, will be taken as sine of I upon sine of R. So you will be having this as sine of, you are having the bracket A plus delta M divided by 2 divided by sine of A by 2. Okay. Now, at this case, you have written the relation here. Mu sine of R2 is equal to sine I. बराबर है? I can put down this relation as mu sine of R, that is A by 2, is equal to, you will be having 1 into sine I. So I will be able to see that the angle of incidence here will be taken as sine inverse of inner bracket mu into sine of A by 2. This is my 11th formula. Got it? आ रहा है यहाँ तक? No, actually in between there is mu. Therefore you cannot cancel it. If it would have been sine inverse of sine, then you could have cancelled it. But after sine inverse, you are having first mu, then sine of A by 2. That is why you cannot cancel that sine inverse. And then you can cancel it. No, it's actually changing the value, no? It's changing the value. That is why how you are writing is not important. There is a term. ये पूरे term का sine inverse लेना है. By when you are putting mu onto this side and sine inverse of sine of A by 2, then you are taking actually inverse of sine of A by 2, and you are not taking the inverse of mu. So I am writing a square bracket here so that you can understand that we are taking the sine inverse of whole of this term in a bracket. So that is the reason I cannot take the sine inverse of sine. Got it? The full term is there. Okay. Now there are few important parts, but actually before I proceed, you change the place, but I am looking at you. Formula number. शतक हो गया ना? सेंचुरी लग गई या नहीं? मेरे लिए मत बजाओ, आपके लिए बजाओ, क्योंकि आपको हर फॉर्मूला 100 बार लिखना है, तब जाके याद होगा. The point is 110 or less than that. Okay. Now the idea is very clear that these formulas are going to help you more. There are few important points that we would like to cover, and after that you have to give me a presentation. I've told you 2 minutes. Everyone has to come in front, tell your names, and talk about whatever part you have learned from me. So prepare your mind accordingly. It will be recorded. So just mention few points there. For a given material of a prism, comma, light and angle of incidence as the angle of prism increases, angle of deviation also increases. Delta is directly proportional to capital A. Now, why this part has been given to you? So that you can understand, if you are given two prism, One is having angle of prism 30 degree and another one is having the angle of prism as 60 degree. Which prism, for giving the same angle of incidence, same material, same refractive index are used there, which prism will produce more angle of deviation? 60 degree will produce a more angle, 30 degree will produce a less. Even if you are comparing with 45 degree angle of prism and 70 angle of prism, still you will have the same relation because angle of deviation is directly proportional to the angle of prism. Okay? Second point in it. For a given angle of incidence, comma, angle of prism and light as material of the prism is changed, as material of the prism is changed, deviation will also change. Greater the refractive index of the prism, greater the refractive index of the prism, greater will be the deviation. Greater will be the deviation. Delta is directly proportional to mu minus of 1. Delta is directly proportional to mu minus 1. If refractive index of material of the prism is more, delta will be more. If refractive index of material of the prism is less, delta will be less. Getting it? Next point. For a given angle of incidence, angle of prism and material of prism if wavelength of light is changed, deviation will also change. As mu of the prism is different for different wavelength. As mu of the prism is different for different wavelength. Now you are aware of the fact that refractive index mu is proportional to 1 upon lambda. So when we are looking at the Vibgyor, this is arranged in the increasing order of the wavelength. So you are able to see that refractive index will be in a decreasing order. So I will be able to say here refractive index for the red color and refractive index for the blue color. कैसे रहेगा? वेवलेंथ इंक्रीज हो रही है, इस तरफ वेवलेंथ इंक्रीज हो रही है, तो आपका रिफ्रैक्टिव इंडेक्स इस तरफ डिक्रीज होगा. लैम्बडा आर विल बी ग्रेटर देन लैम्बडा ब्लू, सॉरी म्यू रेड विल बी ग्रेटर देन म्यू बी. आपका लैम्बडा का रिलेशन क्या है? लैम्बडा आर, ये लेस रहेगा, सॉरी, lambda r is less than lambda b. greater than lambda b. So you will be having mu r less than mu b. बराबर है, इनवर्स रिलेशन है दोनों का. तो इसका मतलब क्या होता है कि when you are writing delta proportional to mu r minus 1 and delta b proportional to mu b minus of 1. So what will be the relation of angle of deviation for the red and the blue? किसका ज्यादा रहेगा, किसका कम रहेगा? ब्लू का ज्यादा डेविएशन रहेगा, रेड का डेविएशन कम रहता है. That is why when you are passing a white light through this particular prism, you will be able to see that the red will be appearing to you on this side. This is red. And you will be able to see that the violet will be appearing to you onto this side. This is violet. So in that case, you will be having here the spectrum V, I, B, G, Y, O, R in that manner. So if you remember and recollect the part which we have studied earlier, how is the speed of red? The greatest one, the maximum, so it suffers minimum deviation. Whereas speed of violet light is minimum, so it suffers a maximum deviation. So how that deviations are taking place for red light to violet light, this will be the region which you will be calling it as a spectrum. इसको आप कहते हो spectrum. Because you are able to observe those colors in that order, that is why we are able to call it as a spectrum. Red will be at the top, violet will be at the bottom. Normally we memorize Vibjor. But in a prism, when a light is getting dispersed into the constituent color, red will be at the top and violet will be at the bottom, because red light suffers less deviation, violet light suffers more deviation. Have you got this? Pakka? You are having an equilateral prism and we are making a white light incident on a prism ABC. At the point of incidence, I am putting a normal here. It is traveling from rarer medium to the denser medium inside the prism, and you are aware of the fact that refractive index of the prism is inversely proportional to the wavelength. So you will be able to see that the colors will be splitted at the first face only. यहीं पर splitting शुरू होता है पहले फेस पर. One ray will be traveling along this direction. Initially they will be traveling, they should have traveled along a straight line path here. This is the original path they should have traveled in absence of prism. There will be one ray that will be splitted along this direction. The second ray will be splitted like this. And then from here, again, we will be showing a normal drawn. At this point, again, the normal will be drawn. You are able to see here, the red light will be coming here. And you will be having the violet light coming onto this side. Now, if I extend this line in a backward direction, this is representing to me angle of deviation for the red color. And if I extend this to backwards, this will be representing to me the angle of deviation for the violet color. So angle of deviation for the violet color is going to be greater than angle of deviation for the red color. Red color is having a minimum deviation. Got this figure? Now, mention there. In case of dispersion of light, the angle between extreme rays is measured, the angle between the extreme rays is a measure of dispersion. The angle between the extreme rays is a measure of dispersion and is called angular dispersion. And is called angular dispersion. So you mention here angular dispersion is taken as theta is equal to delta V minus of delta R. नंबर कौन सा आएगा आज का? नंबर 15th 12th 14 हो गए थे ना. ओके तो कितना नंबर दूं? Next line. The ratio of dispersion to the mean deviation, is called dispersive power. So it is given by dispersive power is equal to omega is equal to delta V minus delta R divided by mean deviation. Delta is standing for mean deviation. What is the unit of angular dispersion? It will be degree only. Deviation angle degree में ही रहेगा. And what will be the unit of dispersive power? It will be again dimensionless. Okay. So you are having here, for a prism, we have already mentioned that value of delta is taken as mu minus of 1 multiplied by A. So your omega, that is dispersive power, will be taken as delta V minus of delta R divided by mu minus of 1 multiplied by A. I can further write down this relation as mu V minus 1 multiplied by A minus of mu for the red color minus of 1 multiplied by A divided by mu minus of 1 multiplied by A. So you will be able to get here mu V minus of 1 minus of mu R plus 1 divided by mu minus of 1. So you will be getting this as mu V minus of mu R divided by mu minus of 1. Mention there. हो गया? Formula can be numbered. Huh? This formula is to be numbered. A single prism produces both A single prism produces both deviation and dispersion simultaneously. A single prism produces both deviation and dispersion simultaneously. A single prism cannot give deviation without dispersion or dispersion without deviation. However, if two prisms are combined together, we can get deviation without dispersion or dispersion without deviation. So, have you understood the last line? Understood the last line? You are having one prism. When you are passing a white light through it, then it gets dispersed on the other side. Then you place second prism in anti-parallel position. Then again you are getting a white light. Am I right or not? So you are able to see that same length. So it will depend on how you are orienting. Normally we keep the orientation in this manner. One prism is placed like this, and second prism is placed in this manner. Then you are able to see the white light there. White light means what? When you are making it enter at this particular point, it will split into the two colors, into spectrum, dispersion will be there, and again they will be dispersing it. But in this particular case, they will come here together and it will be coming out as a white light. Again it will be a white light. So this is the situation. Deviation without dispersion. This is the situation which is called as deviation without dispersion. They will deviate from the path. Now actually at this end, their path would have been along this direction. If this prism would have been absent, ये जो दूसरा प्रिज्म है और ये पहला प्रिज्म है, ये दूसरा प्रिज्म नहीं होता तो ये पाथ इस तरह से आता ना नीचे, पर अभी ये पाथ ऊपर ही जा रहा है, इसलिए यहां पर डेविएशन हो रहा है, पर डिस्पर्शन नहीं है. यानी यहां पर आपको 7 रंग नहीं दिख रहे हैं. आर यू गेटिंग दैट पार्ट? पर ऐसा दो अलग अलग कंडीशन में होता है. कभी कभी हम ऐसे दो प्रिज्म रखने के बाद ऐसे दो प्रिज्म रखने के बाद when you are making a white light incident here, it will split into the constituent color like this. After that, you will be able to see that when it enters here, you will be having red here, violet here. After the second prism, the red will be traveling less. It is deviating less. And this will be deviating more. And afterwards, it will be traveling like this. So you will be having violet here, red here. So this is the situation where you are having dispersion. This is the situation which you are having dispersion without deviation. ये सिर्फ आपको इसलिए मैं बता रहा हूं बिकॉज द परसेप्शन क्या रहता है कि दो प्रिज्म अगर एंटी पैरेलल लगा के रख दिए तो हमेशा वो व्हाइट लाइट प्रोड्यूस करता है. ऐसा नहीं होता है. उसकी थियरी बहुत बड़ी है. इट इज नॉट यूजफुल टू अस, सो आई एम नॉट गोइंग फॉर दैट पार्ट ऑफ द थियरी, बट जस्ट आई एम गिविंग यू द आइडिया कि व्हाट इज डिस्पर्शन विदाउट डेविएशन एंड डेविएशन विदाउट डिस्पर्शन, वो कैसा रिलेशन है उसके बारे में सिर्फ आपको पता होना चाहिए. There are two more points to be added. A ray of light will not emerge out of a prism, whatever be the angle of incidence, if angle of prism is greater than twice the critical angle. If angle of prism is greater than twice the critical angle. Or refractive index of material of the prism, is greater than cosec A by 2. Cosec A by 2. Next point, the light will emerge out of a prism. The light will emerge out of a prism only if angle of incidence is greater than I minimum, which is equal to sine inverse of under root of mu square minus 1 under root of mu square minus of 1 sine of A minus of cos of A. This will be again numbered one. Huh? In this situation, the deviation will be delta is equal to I1 plus 90 minus of A. Angle of deviation would be I1 plus 90 minus of A. I'm not giving you the proof of that. That is not required for us because that will be of a higher end. But you should be aware of this will actually cause the ray not to emerge out. आप समझ रहे हैं क्या? यानी इंसिडेंट रे तो यहां से दे दिया हमने, पर ये इंसिडेंट रे जाने के बाद इट विल बी हैविंग द ग्रेजिंग इमर्जेंस या ग्रेजिंग इमर्जेंस के पहले वाले जो सिचुएशंस है दैट हैज बीन कवर्ड देयर. पहले पार्ट में ये बताया कि इट विल सफर अ टोटल इंटरनल रिफ्लेक्शन, इसलिए वहां पर क्रिटिकल एंगल आता है. सो दैट पार्ट यू शुड बी एबल टू कवर इट अप. So this actually covers the theory of whole prism that is there. I've seen it in the NCERT book. It is only of one page. Just check it out if I'm right or wrong. Theory of prism is only on one page. So you can imagine we have worked for around 2.5 hours. एक ही पेज पर शायद. Page number 239. Now I was talking with Sai Prasad sir. So I have requested him to show you my videos on ray optics specifically in continuation. Have you got me? The same part will be there. The same part will be discussed also. So if you are looking at those videos, at least ray optics will be completed with the help of a video lecture. I want to get the response from you, so you can post the response to sir and sir can hand it over to me. If you are having any doubt in that particular part, you can ask me the doubt via ma'am or via sir. Ki this is the area we want to have a doubt. I can come online and explain you how the concept is there. Okay. So I want one topic to be completely dealt. That is why I have given all the video lectures. Almost 480 lectures I have given to sir, so that you can have most of the things in physics that could be dealt with. Only one chapter is not there, that is work energy power. Okay. But I was unable to take that video lectures there, so I was unable to put it to you also. This is the part up to which we are able to deal it. Now, I will be requiring again the same data and whatever pages you are having for NCERT, I'll count it and I'll take that particular part stuff. But how many pages you have worked, I should know the range, because somebody is talking of 200 pages and somebody is talking of 40 pages. I should know the row. Six zero. Yeah. $47. Anybody lower than 47? Lower than 45? Lower than 45? Maximum? 73 I heard. So it's easy for me then, 45 plus 80 divided by 2. So around 60 pages can be definitely taken. 60 pages approximately can be taken? Okay, no problem. And the formula list? One, 114. Did you make the list or not? 114. Okay, one more question to all of you. How many ray diagrams are there in your copy? Including the problems one, huh? Now, just two important points there. Now, I have covered some options, some parts there from the ray optics and optical instrument, introduction, reflection of light by spherical mirrors, refraction, total internal reflection. I have not covered this topic, refraction of spherical surfaces and by lenses. Refraction through prism, I have covered, right? And optical instruments are not covered. Lenses part, I have given you the idea. थोड़ा सा उसमें काम करना पड़ेगा, but after you watch the video, they will appear to you much more easier. Lenses, मैंने clearly बता दिया था that concave mirrors and convex lenses are having the same behavior, whereas convex mirrors and concave lenses are having the same behavior. Now, I don't know how many of you are having the book. If you have a book, you can check it out, whether this statement is correct or not, number one. Number two, what do you mean by lens? Because that thing I'm going to tell you, which is not normally given in the book. What is a lens? Convex lens. What is a convex lens? Biconvex lens. The radius of curvatures are equal, then you call it as equiconvex lens or biconvex lens. They are having two curvatures into it, convex lens. But how that convex lens came into the existence? We are aware of the part that every part of a mirror produces the image. We have seen that line. So every lens, every part of the lens will also be able to provide the complete image. Even if you are hiding or you are putting some black color paper over the half of the lens, still it will be producing the complete image. So lens, when I was thinking about it, I thought that we have learnt about the lens. That is why this is the thing that we take it first. Suppose I put down the two prisms in this manner. Got it? And cut it out in this manner. It becomes a lens. Okay? If you want to make a concave lens, this will be giving you somewhat a concave lens. So the idea of lenses have evolved from the prism. So I've created a background for a prism, so you should be able to get it easily. If you are able to understand the convex lens and the concave lens, you will find that telescope and microscope would become much more easier for you. Because telescope or microscope, both are containing only the convex lenses. You got a right position. Okay? Got the basic now? Now, I'll just tell you that if you go through the videos, it will be helpful. But remember one thing, this is only for the part of explanation. Problem solving is very important, and that problem solving would require the efforts to be taken from your side. So that you take it, you will find that this chapter is relatively simple if you practice it more. That is why I asked you how many number of ray diagrams. The number was around 40. Now, by practicing around 40 ray diagrams, I can tell you your confidence level in handling the ray diagram will be more. Okay? So this is the part.